Okay, so last time we talked about UI componentization. So this is a to-do list. You can see the visual hierarchy, but in code, we're going to build it out as a code object hierarchy. Like at the top level, there's an app, and then we have a horizontal box, and then there's a text field, and then there's a button, and then actually before the horizontal box, there's a V box, inside which there's a horizontal box, and then maybe there's a list, and then there's item 1, item 2, item 3. We built this tree to represent this visual hierarchy here. What I want to talk about this time is how do you go from this tree of objects to this visual? That process is the layout and the paint. First, there's the layout, and then there's the rendering.
So by layout, you mean where do you draw stuff?
Yeah.
Or what is the boundary of each
Yeah.
one? Okay.
Imagine if I assigned each node within the tree a position and a size. Each guy has a position is something and a size is something. Maybe size is 100 by 500. Imagine I already gave you a layout engine, and the layout engine will magically give each element a position and size. With that information, if I asked you to draw the UI, it's actually relatively straightforward because I need to draw app. How do I do that? Well, I know the position, I know the size, so I draw a rectangle, well, with rounded corners, starting at this position with this size. And that's true of many of these boxes that I've drawn. Most of them are just boxes, right? So you just draw a box at where you're supposed to draw the box. With the text, well, just in addition to drawing the box, you also draw some text. How do you know where to draw? Like the text field will have to draw some text. The button will have to draw some text as well. Calculate based on the font size of the text, how tall does the text need to be? And if you need to center it, then calculate how long the string will end up being in that font size. And then you try to center it within the box. So there's some math involved. But other than that, it's kind of straightforward. I mean, if you've never done any kind of graphics programming like that, where you have to deal with XY coordinates and stuff like that, it takes a little bit of getting used to, but once you are familiar with that, it's straightforward. So let's spend more time on the layout. It's like, how does the layout work? How does a program magically figure out the position and size of each element on the screen? It is a recursive tree walk. If you looked at enough recursion problems, pretty much whenever you see a tree, you know it's recursion, right?
So do you walk from the top to the inside, or do you walk from inside? So like, does the outside decide the inside, or does the inside decide the outside?
So initially, I tried to come up with my own way to do this, and it worked okay up to a point. When I sort of got stuck trying to do scrolling, and I did some research, and I found a Flutter's layout algorithm. I want to spend some time talking about their algorithm, but before that, let's just talk about the problem in general. Maybe just simplify this picture a little bit. HBox, it's a component that will lay out its children horizontally, right? So this is an HBox. If I add one component into it, it would go here. If I add another one, it would go here. If I add another one, it would go here, etc. Now, in the case of our UI, we actually wanted the text field to stretch. And then the button to take up the rest of the space. In CSS, nowadays, people normally use flex to do that. In my framework, I have a concept called stretch. So I say this text field has stretch in the direction of X. So I would do something like when you add the child, you say, I want to add to the H box, the text field, with a stretch in the X direction. One observation is I want the H box to be responsible for the layout. That's important because if it were a V box, then I want the V box to do the layout in a different way, right? Mm-hmm. So I want the layout to be not a responsibility of the framework itself, but the responsibility of the elements. In particular, the elements that act as containers. And elements that are like text box, text field, and button, they're not necessarily containers. They will not need to worry about laying out children within them. They still handle the layout of themselves. At this point, we could take that to mean decide what your position and size are going to be. So the initial scheme that I did was each element would have a layout method. It'll end up having some parameters, but for now, let's not worry about it. If hbox was the root of your UI tree, you're going to call layout on the root of the tree. Because hbox is a container, it has the responsibility of going through each of its children and telling them to lay out.
So does only containers have layout method?
No, because I have to call layout. I have to be able to call layout on my children as well, and my children are not necessarily container.
So what do the non-container element layout do?
In my original algorithm, it has to decide where its position and its size are. But with the flutter algorithm, it relaxed it and reduced it to decide what its size is only. And it defers the position until later. Back to this example. So after I call child.layout, I should expect that child.size exists and has two numbers in it. And I can receive the width and the height of child.size like this in Python. So now that I have the width and height of my child, I can use that to calculate what the hbox's size should be based on what each child's size are.
But how do you know the stretch element size? Like in your example, I probably can calculate how what's the size of the button based on the text. But what about the left? The text. Because you don't know the parent size yet, right?
Exactly. Yeah. It's actually kind of tricky. And I will tell you about Flutter's algorithm. I also want to give a shout out to this guy, Jeremy Rose, because his article is how I learned about Flutter's algorithm. And this article was very helpful for me. He said he researched a whole bunch of different layout algorithms, including the Qt one, and the Swift UI one, and CSS. And he decided to go with Flutter because it's the simplest one. I found it. Flutter's rendering pipeline by Adam Barth. I just want to reference it because this is a main source of my research. When you're laying out something that can contain some elements that are stretched and others that are not. After I tell you, it's actually going to seem extremely obvious. Wait. I have to tell you the secret first, though. The secret is the layout function has a parameter, which is called constraints.
Okay.
And what's a constraint? We'll pretend it's TypeScript. Has a minimum width, maximum width, minimum height, maximum height.
Oh, wow.
That's it. That's constraints. If you are an UI element, like let's say you're a text field or you're a button, or let's say you're an hbox, you're responsible for implementing your own layout. And your layout method is going to receive the constraints, which is just a set of 4 numbers.
Okay.
All of these are optional. So if none of the numbers exist, that means there are no constraints. You you can choose whatever size you want. For the layout phase, all we're concerned about is coming up with your size, which makes it easier. When we render, when we actually draw things onto the screen, that's when we come up with what the position should be. So the layout is one walk through the entire tree. The rendering is another separate walk. But the layout phase, we're only concerned with the size. So let's say you're the text field. Your layout method is called. If you don't get any constraints at all 4 of these numbers are not specified. You get to choose what your own size is. For a text field, the obvious choice would be, I'm just going to make myself as big as my text needs to be. Maybe my text is add. In my case, I can't control the font size because I'm in the terminal. Then I'm just going to return 3 characters across and 1 character vertical as my size. If you're pixel-based graphics, then based on the font size, you calculate the size that is required to fit in this word.
So in this case, because the recursion is from hbox to its children, right? So when you call hbox.layout, you have the constraint, which probably is the apps.
Yeah, exactly. So initially, we call hbox.layout with the constraint. Initially, we want to use the size of the screen to constrain these things. That's what you're thinking here. So you're thinking like we want to give the maximum width as the screen width and the maximum height as screen height. Yes.
Right.
You're right. You're right to assume that. Yes. With just these 4 numbers, you can either give a lot of freedom for your children to choose or very little freedom. But the way you can give very little freedom for your children is by fixing all 4 numbers. I want my child to be exactly 50 by 40, let's say. Then what I would do is child.layout min width 50, max width 50, min width 40, max width 40, right? So this is one of the strategies that you can use. Another strategy would be like, hey, I want my child to decide. Well, you don't have to specify anything, or you could be loose with respect to the minimum. Than you at most. So you use a combination of these strategies to achieve the layout that you want. So now coming back to the hbox layout where you have some some elements stretched in the x direction. So what you want to do is first you pick out your non-stretched ones. Non-stretched equals like you do some kind of filter your children in some way to get the non-stretched elements that you have, and then you ask each of them what size do they want to be for child non-stretched. You say layout, and you're very relaxed about what size they can take. So you just don't give them anything. You just you just tell me your best guess as to what your size is, and then after you lay out, I'm gonna have your size. And I'm gonna get a child width and a child height after you lay out, and then I'm gonna add them all up, non-stretched total width, right? And I'm gonna add that. So at the end of this loop, I have the total width of all the non-stretched elements. I'm gonna have the stretched ones as well.
And then now you can know what's the remaining space for the stretch.
Yeah, remaining is going to be like my constraints dot max width minus the non-stretched total width. And I take this remaining and I spread it across the ones that are stretched.
So what if you have 2 that needs to stretch? Do they like each of them take half?
Yeah, each of them take half.
Okay, that's cool.
And you do something like width per stretch equal remaining divided by how many stretched there are. Right? This is the width per stretch. And then you go through them for child in stretch. This time you use the other strategy, which is to very strictly determine what their size should be. and you say, hey, I want your min width to be that width I'm going to specify. And your max width is also going to be that.
Okay, gotcha. I
Does
see.
that make sense?
Yeah. Makes sense.
And actually, I sort of didn't think about the height, but you also want to specify the height as well. But since we're in this case, since we're laying things out horizontally, and we're doing something like this, right? The height constraint I want to give each child is probably more or less the same height constraint that I got, right? Because I want the child to be as tall as it can. But minus the padding, basically it should be based on my own height constraint, which would be like, so I pass on my height constraint to my children, basically. And also, at the end, I still have to come up with my own height and width. So my width is going to be the sum of the widths of all of my children. And my height is going to be the max of the heights of all my children.
Yeah, that makes sense.
Initialize it at 0. So once I get the width, I'm just going to say my width plus equals to my child's width each time I get a child's width. And I'll do the same here. And then my height is going to be the max of the current my height and the child's height. And I'll also do that over here. So at the end of both of these loops, I have my height and my width, and I can do something like, hey, my size is my width and my height. So now I have my size, and that's how I calculate my size for an HPOX layout.
Nice.
Yeah.
That's cool. Yeah. So the key calculate the non-stretch ones first.
Yes. And this constraints trick is like it might seem like obvious, but it was not obvious to me that just 4 numbers as the constraints is the only thing you need to be able to build very, very flexible layouts. And I think that's extremely cool.
Yeah, I think this makes sense because the complication before was like whether the children decide parents' size versus parent decides children's size. But this like makes it the constraint basically provides some sort of parameter of the parent, and then still the parents is size finally is decided by the children. So I like how this.
Yeah, you need communication both ways. You need it's like a handshake kind of thing. The parents like, oh, I don't know what my size is until I know what my children's size are. But then the children are like, well, I am somewhat flexible. If you give me more space, I'll take it. I think it's pretty remarkable that this scheme, it's a very, very simple rule set. Like the only rule is that every element in your UI tree must implement this layout method that takes in these constraints, which are these 4 numbers. And it has to respect the constraints. Like if you're told your max height is this, you're not allowed to set your size to more than that. But each number is optional. So if they're not there, there's no constraint. You can make your size infinite size if you want. And with just that, you can create very complex layouts. At least that's what the Flutter team told me. They mainly focus on mobile apps. They basically showed many complex mobile app layout, and they're able to achieve all of those with this just very simple scheme.